Hello students, my name is Shashank Shekhar. So we have started the chapter Some Basic Concepts of Chemistry, in which we have seen the classification that matter can be divided into three types: solid, liquid and gas. So we have seen some properties of solids, that they cannot be, they have a different shape and different volume. The interatomic force is highest in case of solids. Then we have seen that the kinetic energy of the particle in the solid is highest, and if you talk about the fluidity, it is least in solid. Further, we have seen in liquid that they have a different volume but not a different shape. It takes the shapes of the container in which it is kept. Then the interatomic forces, it's the middle is the mid core in case of, means it is medium in case of liquids, and their kinetic energy also falls in the medium category. Its fluidity is also in the medium. And the next we have seen that in case of gases, the kinetic energy is the most for gaseous particles, but the interatomic force is the least, and uh, they do not have a definite shape. Neither they have a definite volume. Okay. Now we will try to classify the matter on a different basis. So matter can be basically classified into two types, that is mixtures and pure substances. So as the name suggests, mixture means which is formed by mixing pure substances, that is made up of only one type of thing. In mixing comes two types, that is homogeneous and heterogeneous mixture, and in pure substances we have elements and compounds. Okay, so we can say that when all the constituent particles of a substance are same in chemical nature, then it is said to be pure substances. Whereas in part mixture, we contain two or more pure substances which may be present in any ratio. What is the meaning of this? So it says that if we take a particle of a substance, then we take another particle of substance, then we take three particles of substance, suppose, and if all of those particles that we are taking subsequently, if all of them are identical, then we say that they are pure substances. Okay, so for example, you take a sugar, right? Now the molecular formula of sugar is C6H12O6. So each of the particle that is present in sugar, so that will be always C6H12O6, means each of the molecule will have the same composition of carbon, hydrogen and oxygen, that is 6 carbon, 12 hydrogen and 6 oxygens. Okay. Now on the other hand, if we talk about mixture, so they are formed by mixing two or more pure substances. What can be the example of mixture? Suppose we take water, okay, and we pour say oil into it, right? Now you will see that water is a pure substance, oil is a pure substance. After mixing both of those, you will find an impure substance, because these substances are different, they are distinct. Okay, so if you take a particle from one side, take a particle from different side, suppose you are taking particle from the up of the water, then the chance is that the particle which you have taken is a oil particle. But if you take particle from the downside, from the bottom side, then the chance would be that it is a particle of water. So that is a example of mixture, because all the particles are not identical. Clear? Now the composition of mixture is variable, as I have said. So we can take another example. Suppose you are dissolving soil into water. Now since soil is heavy in nature, so it will settle down, most of it will settle down, some of it will be dissolved in water. If you just try to measure the composition of soil at the bottom, you will find that the composition is not same. First of all, soil is already a mixture. If you take soil and try to measure its composition, you will see that it has different composition of minerals and metals at different points. Okay, so for example, say the soil of your uh, uh, desert areas is different from the soil of the areas that are situated near river. Okay, and it would be different from the, say, your soil that is present in near the lava. So all types of soil will show different type of characteristics, and even the soil that is taken from a same area or a same part of the sub earth, that would also have a different composition. So it is a mixture, and a mixture is how it is formed. It is formed by mixing two or more pure substances. Now pure substances forming mixture are called its components. Many of the substances present around us are mixtures. So whether we talk about sugar solution, it is also a mixture. How is it a mixture? You will say that it is made up of sugar and water, it is fixed. No, the composition can change. Okay, so you can dissolve 1 tablespoon of sugar in water. You can dissolve two uh, 2 tablespoon of sugar in water. So they both will be sugar solution, but the composition will not be same. So it is a example of variable composition. Therefore, it is a mixture. Again, if you take air, then air contain different type of dirt particles and different type of gases like nitrogen, oxygen, water vapor. Okay, so that is variant, and we cannot say that air is a pure substance. Next example is tea. Okay, your tea is also not a pure substance because it is a mixture. Some of, if it would contain your water, it will contain your ice. Sorry, it will contain tea. It would contain sugar. Okay. Now, a mixture can be homogeneous or heterogeneous. What is the difference between homogeneous and heterogeneous? So, in homogeneous mixture, the composition of the, say, solution is same throughout. What is the example? The very common example would be sugar solution. So, if you take sugar solution, so if you dissolve it properly, you will find that at the point of complete dissolution, you will find that the concentration remains same. Sorry, the taste remains same. So if you take different sips of that sugar solution, you will experience the same approximately same amount of sweetness. Yeah, it is a different thing that at the bottom most of the sugar is deposited. But suppose we take an ideal situation that all of the sugar has been dissolved. Then in that case, you will find that the sweetness remains same. Therefore, the composition of sugar throughout the water is same. Okay. But if you take a heterogeneous solution, the composition is not same throughout the solution. It will change. It will vary. Okay. And in some cases, the components are also, means they do not completely mix, and the components are also visible. Suppose you take white sugar and white sugar not. Suppose you take white salt and mix it with black salt. Now that will form a heterogeneous mixture because it will not mix completely, and the parts of black sugar or the black salt and the white salt will be visible separately or individually. Okay, got it? So for example, mixture of salt and sugar, grains and pulses. If you take the mixture of grains and pulses, that would also be visible along with some dirt stone are heterogeneous mixture. The component of a mixture can be separated by using physical methods. So they can be separated. How it can be separated? If I ask you the component of a mixture can be separated how? Suppose you have taken a mixture of sugar and water and now you want to separate it. Now if you start heating this, the water will escape as water vapor, and since sugar will not escape, it will be crystallized again and you will get your sugar back. Okay. Now if you put a funnel on that, say, container, then the water can also be collected on the funnel. Or if you connect a pipe through it and keep a beaker at the end of the pipe, then also you will get the water collected at a different place and your sugar collected at a different place. Then you must have seen in your home that whenever grains are being bought from, say, this shops, then your mother must have picked the stones or the external particle which are not required. Your mother must have picked those particles and kept that out. So that thing is called hand picking. Or through filtration. So what is filtration? So in filtration, suppose you must have seen the RO, UV, and your filter paper also. So if you take a filter paper and pour water on it, then the filtrate will be filtered out, and the water which the pure water which is say passed through the filter paper will be collected in a beaker. Then this is distillation. So distillation can be of various types, fractional distillation based on thermal solubility and all. So this is the uh, separation techniques for your mixture. Now if we talk about pure substances, then they can be further classified as elements and compounds. Okay, they can be further classified as elements and compounds. How are water particles and what are elements and water compound? So elements are those whose constituent particles are of only one type of atom. Okay, so this particle may exist as an atom or molecule. Now if I take the example of an element, we can have oxygen, we can have helium, we can have hydrogen, we can have H2. So all of these are elements, although it is made up of two particles, but you will not see it as a compound because the constituent particle are same, oxygen and oxygen. Okay, so for that reason it is an element, not a compound. So they can exist both as an atom like helium and as a molecule, that is O2. So we have example of sodium, copper, silver, hydrogen, oxygen, etc. So all are the example of elements, right? Now some elements such as sodium or copper contain atoms as their constituent particle, wherein some others the constituent particle are molecules. So they can vary. The constituent particle can be atom also or molecule also. So in case of sodium we have Na, that is sodium atom. Copper we have copper atom. Okay, whereas in case of molecule they can be more than two atoms. So example, if we have sulfurate, so it is also an element. Okay, then we have oxygen, we have chlorine. So all of these are molecules but elements. Now if the constituent particles are not same, like our H2O, that is water, so it contains not only hydrogen but oxygen also. Or if we take carbon dioxide, we have carbon and oxygen also, right? So they are not elements but they are compounds. For example, hydrogen, nitrogen and oxygen gas consist of molecules in which two atoms combines to form respective molecules, right? So here is an illustration for that. Atoms of different elements, hydrogen, oxygen, nitrogen, copper, sodium. So when two such combine, they combine to form hydrogen molecule, which is a element, right? Again, an oxygen atom and a second oxygen atom can combine to form a molecule of oxygen, which is again a element. Got it? On the other hand, if two or more atoms of different element combine, suppose we are combining hydrogen and oxygen, okay, so although they combine a different ratio, means always two hydrogens and one oxygen will combine, so therefore the ratio is fixed, that is 2:1. So in that case the molecule of a compound is obtained. So this is a compound. Moreover, the constituents of a compound cannot be separated. So they cannot be separated. It is very difficult to separate hydrogen and oxygen into separate substance by physical methods. You can pass electricity with and separate it, but not through physical methods like hand picking or crystallization, okay, or distillation. They can only be separated by chemical method. Example of some compounds of water, ammonia, carbon dioxide. So here the example, the molecule of water and the molecule of carbon dioxide. Again, a water molecule comprises of two hydrogen and one oxygen atom. A molecule of carbon dioxide contains two oxygen and one carbon atom. Okay. The atom of different elements are present in a compound in fixed and definite ratio, and this ratio is characteristics of the particular compound. Also, the properties of a compound are different from those of its constituent elements. For example, hydrogen and oxygen are gases, whereas the compound formed by the combination, that is water, is a liquid. What does it mean? It says that hydrogen and oxygen both are gases. Now, two gaseous atoms can combine to form a different state, that is liquid. Now, hydrogen burns with a pop sound and oxygen is a supporter of combustion, but water is a fire extinguisher. So if I talk about physical chemical properties, suppose we are say exposing our hydrogen to fire, then it will burn with a pop sound. But if I talk about oxygen, then it is a supporter of combustion. Whereas if you put water on your water fire, then it will extinguish or deflame it. So this was about the classification of matter. Okay. So what we have learned today? So we have learned that our matter can be classified into two types. First is pure and second is mixture. First is pure and second is mixture. What are pure substances? So if I talk about pure substances, so they are made up of only one type of particle and their composition does not vary. Whereas in mixture, the composition varies and it is made up of different type of means the constituent particles are not same. Clear? So what do you mean by the constituent particles are not same? So whenever say you are saying that sugar solution, so when we are dissolving sugar into water, neither the sugar loses its properties nor the water loses properties. Sugar is present in the sugar solution in the form of 612H C6H12O6, whereas the water is present in the form of H2O. Okay, so there are two different type of molecules that are present in a sugar solution. Whereas in the case of say water, alone water, we have only H2O molecule that is present. So that is the meaning of your constituent particle should be same. Okay, clear? Now one more important thing you should remember is that what is the difference between an element and a compound? So most of you would say, so if I ask you, if I give you a series of compound, suppose O2, H2O, CO2, Cl2, He, okay, F2, SO2, and say we have C2LH22O11. Now if I ask you that classify them as elements and compound, how you would do it? So first let us talk about oxygen. So is this element or compound? So it is an element. Why? Because the constituent particles are same. We have oxygen only. Okay, it is a element which is a molecule. It is a molecular element, I would say. Okay, this is a molecular element. This is what? This is a compound. Why? Because it is composed of both oxygen and hydrogen. Next, if I talk about CO2, then it is composed of carbon and oxygen, therefore it is also a compound. Now Cl2 is only composed of chlorine, so therefore it is a element. Helium, so it is only composed of helium, so it is an element again. This one is also an element. SO2 is made up of sulfur and oxygen, so it is a compound. C2LH22O11, it is also composed of carbon, hydrogen and oxygen, so it is also a compound. Okay, so you should be very clear about what an element and what a compound is. So this was the classification of your pure substance, elements and compounds. Now if I ask you what is homogeneous and heterogeneous, so as we have discussed, so homogeneous mixture are something in which concentration is same throughout the mixture. In case of homogeneous, but in case of heterogeneous, concentration is variable throughout the mixture. Concentration is variable throughout the mixture. Suppose I gave you a question to solve. Suppose we have figure solution, water and milk, water and oil, soil and water, right? Paint and oil, okay? Then we can have wheat plus rice. Now, what can you tell about homogeneous and heterogeneous mixture? So, if all of the sugar has been dissolved into water, then figure solution will be homogeneous. What about water and milk? So, to decide this, you have to see whether both of these are polar or not. So, since milk contains the content of milk is mostly water, and if it dissolves it in like dissolves in like, so it is forming a homogeneous mixture. If you talk about water and oil, so since oil is non-polar, so the does not dissolve, and because the density of oil is less, so it will float on the surface of water. Therefore, they are already separated, so it is a heterogeneous mixture. If you try to dissolve soil in water, it will never dissolve completely, and some of these will be deposited on the surface or on the bottom. Then in this case also, it will form heterogeneous mixture. Paint and oil, they both are non-polar, so it will form homogeneous mixture. Wheat and rice together will form heterogeneous. We cannot dissolve it properly. Okay. So far we have done the classification, and in the next class we will see some of the questions related to it. This was for today's class. Thank you.